domain-driven design is not really something that even I myself have practiced concretely in my day-to-day, but it has definitely affected the way that I see how software can be built. And in what direction can software be built better, at least for certain classes of software problems that I think are quite relevant for many of us. So that's why I kind of want to talk about these like domain-driven design a bit more. So I'll start sharing my screen so we can start talking about it. Okay, so thank you for coming, everyone. And this talk is about domain-driven design. So let's start off with a question. Actually, before asking like what is domain-driven design, I just want to ask how many people here have heard or worked with or know of a domain-driven design? Just want to see a show of hands. I think you can do that through the chat, just to get like a sense of whether people know about it.
And this is not a test.
Yeah, not a test at all.
I didn't hear about this until like 6 months ago. So do not be like, don't feel bad or anything. All my, idols are rockstar developers. I'm not even gonna lie. I only like look at Twitter to look for opinions.
Okay, so there's 2 people. I mean, or maybe 3, or maybe 4. Maybe I lost count already because it's kind of like mixed in between the video chat and the textual chat. But yeah, at least some people know, and hopefully they can to help answer some questions later on or give better insights than I can do, and hopefully I don't butcher things too much for more experienced people. But domain-driven design, let's start off by just giving a historical context. It's a technique. It's a design technique that is created by Eric Evans, or at least like a pioneer, and really driven by someone called Eric Evans in 2003. Whoops, sorry. I'm not sure what that was. Yeah, pioneered by Eric Evans in 2003. And it's kind of, I guess like it was very popular in the early 2010s or the early 2000s when they first came out. Kind of subsided, and it now there's more talks about it, especially with the the more common usage of microservices, because it's often, though not directly related, it's often used as a guiding principle, as a design guiding principle. So that's kind of like the historical context behind it, roughly speaking. And primarily, this domain-driven design is it's a design technique with technical aspects to it, but at the same time, I think the more important parts of it is the philosophical concepts, or the at least the ideas, the conceptual ideas that underpins domain-driven design. I think those are more important, and it's really the core part of it. And all of the technical phrases that domain-driven design espouses, things like I'm just giving examples here. Things like entities, value objects, aggregates, repositories, factories, transactional consistency, context mapping, all of these things that are very technical, that's for sure. Under the hood, they're underpinned by a set of few beliefs and a set of way of thinking of how to best handle the complexity of software. And towards the end, I'll try to give a bit more technical examples just to relate all of the more conceptual and more philosophical ideas together. And hopefully they'll kind of tie things together. Oops. Yeah, so tackling complexity in the heart of software. When I see, from my understanding of DDD, there are some assumptions made by DDD, and that kind of like makes it worthwhile to do domain-driven design. Without it, it's like, why are you using domain-driven design? So in the get-go, it must be known that domain-driven design is not for all classes of problems in software, but arguably it's a large. At least Eric will argue so, that a large number of software problems that we tend to deal with are able to be solution using domain-driven design well enough, at least. So at the very premise of it, domain-driven design is meant to solve complex software problems, and that the complexity arises not from the technical requirements, not things like what database you should use or what framework you should use, but the complexity arises from the business requirements. And the best way to tackle the complexity, because the complexity arises from the business requirements, is by understanding the business and what Eric would call understanding the domain. So to continue on, the difference between complex and complicated can be, it's a linguistic aspect to it, but some people try to make a differentiation, especially in the world of engineering, like mechanical engineering or physical, or like not chemical, but those more hardware oriented physical engineering. They have a sense of complicated versus complex. And I'm just taking it here from Stone Review that essentially complicated problems are problems that you can solve using a set of steps, very algorithmic in nature. And complex problems are things that kind of emerge, that the complexity or the hardness of it kind of comes about because of the various interactions within the system, or just that there are nuances that are very hard to capture just through algorithmic procedures. So here's an example of a complicated software system. Assume you have some write system that needs to serve 1 billion users. For many of us, I think this is quite complicated to do, and it will require you to do, very well structured infrastructure. It should be able to handle a lot of load. You need to be able to make sure things stay consistent. There's no downtime, and speed latency is hopefully minimal. Things like no excessive contention issue, and things like that are very technical in nature. And surely this is not an easy problem to solve, but this is not a problem that DDD is meant to solve. This problem is very technical in nature, and it can live independently outside of the business requirements, even though we want businesses to scale and everything. But at the heart of it is not quite what you care about when reading business requirements. Not that often, at least. Not as often as you will think, like, oh, user needs to click a button. After clicking a button, user saves. Right? That's kind of like more of the business requirements that we deal with day to day. And here's a complex system, and I specifically made the complex system, seemingly less complicated, just like a single user interacting with a banking software system. But there's a lot more things that goes on, right? Even from the perspective of one single user. When the user wants to do a series of deposits and withdrawals, gotta make sure that the balance stays even, right? Or at least the balance doesn't go negative, for example. Or if you allow negative, you have to have a set of business rules, say like overdraft rules. And then there's like the sending, right? Well, what if you want to send money and then you also do withdrawal? Which one to resolve first? How do we make sure that, what happens if at the time of sending the balance is not enough? What do we do then, right? Scheduling, like a lot of banking system these days allow you to schedule payments, for example, by linking your some kind of subscription account or something like that, and then setting up some schedules to that account for payments. And then so there's even like the scheduler aspect, like, okay, among all of these online transactions or immediate transactions, there's also kind of something going behind the scene, right? And then gotta make sure that something behind the scene plays nice with the thing that is happening online transaction, right? So there's a lot of relationships, just to say colloquially, there's a lot of relationships and a lot of things that go on. And it's not as simple as the view of, oh yeah, I need to write concurrently using supporting 1 billion users, but all they can do is write. Maybe they can do reads, but it's write, read, kind of simple, simplistic in terms of their relationship compared to this in terms of relationship. There's just more relationships, more things that can happen, more wrong things that can happen, right? So if you notice that I explicitly made this complicated software system example to be very CRUD-ish, very the create, read, update, delete database procedure, just to note that if you have a CRUD system that all it does is very minimal business requirements, very minimal business logic that it needs to maintain or it needs to check for, and all you care about is reading stuff, viewing it in some UI, saving stuff without really caring about what exactly you're saving, or not much at least, deleting stuff, updating stuff. That's not really a good use for domain-driven design. Again, because CRUD systems tends to be, it may be complicated, but it's not complex, not at least in terms of business requirements from the perspective of users and the perspective of truly business operations. Of course, there might be business requirements that entail technical details, but that tends to not be the place to do domain-driven design. So I talked about DDD and how the important stuff with DDD is really about the philosophical aspect of it. And for me, when reading and discovering DDD, there's really 4 main philosophy underpinning DDD and underpins all of the technical discussions and all of the technical jargons that domain-driven design espouses. And these 4 things are domain, language and meaning, context, and models. And a really important part of domain-driven design is doing it in a collaborative and continuous fashion. So domain-driven design really works well with agile methodologies, assuming that you are really doing agile in the sense of the agile manifesto, that individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. I'm not talking agile in the sense of Scrum or Kanban or Agile or Scrum at scale or things like that. Not these agile in a framework perspective, but the essence of agile, no matter how you do it, whether it's extreme programming or otherwise. But yes, so domain-driven design is best served if you iterate continuously over time, because again, domain-driven design is supposed to help you solve complex problems, and often complex problems can't be solved in a very short amount of time. you probably need several iterations to kind of flesh things out over time and to improve things over time. So it's really important to understand that domain-driven design is, emphasizing these 4 philosophies and underpinned by the assumption that you can and you are in an environment that you can be in a continuous collaboration with your, between developers and stakeholders. So let's start with domain. And I took from Oxford Language. The domain is just a specified sphere of activity or knowledge. And funny enough, that the domains can nest. Right? You have a sphere of knowledge or activity. Say it's science. Inside science, maybe there's something more specific to science, which is chemistry. Inside chemistry, there's something even more specific, biochemical, for example. Right, so there's that nesting aspect to it, and also you can relate one domain to one another. For example, physiology with sports. There's some kind of connection there, right? You can be expert in one of those independently, but also you can be expert in jointly together. And of course, because the name of the design is domain-driven design, the key point is to understand the domain, and is to understand the sphere of activity and knowledge that you are operating in. And who else better to, or who else is more expert at the domain in the business other than the business people or the domain experts? Now, usually us developers or software engineers are not as proficient in the domain, in the business domain as the business people. That's why domain-driven design asks us as developers and as software engineers to consult and talk to the domain experts continuously and often, and discuss things with them to gain knowledge about the domain from them. And it's a lot more than just getting a series of tickets and requirements getting laid out. Oh, you have to do this and that, and this and that. Make this. It's more than that. It's really about teasing out. Okay, you say that the user needs to do X in order to do Y. What is this X? What is this X activity called? Maybe, for example, it's depositing money, right? And then what's the result? It's deposited money, for example, just for a trivial example. So it's really about trying to tease out as much as possible the meaning and language, which gets us to, and there's more of this. So continuing on about the business requirements, it's more of about what does X mean for the user, or what does Y mean for the business? How does X relate to Z? What makes up X? All of these things that are very business operational and very business context heavy. In contrast to less of this, like what web framework to use? Should we use Node.js or Go? What database should we use? Are these cloud providers good? What CI/CD tools should we use? How do we deploy our applications? Which are all very valid questions to ask. It's just not something that DDD cares about. And so it's very important when doing domain-driven design to try as much as possible, separate out technical considerations from business considerations, and really focus on the business consideration to drive your software design, not that your technical considerations driving your software design, which I think a lot of the time we are driven by technical requirements and technical needs. There are reasonable reasons for why we want to do that. A lot of the times it's related to speed, latency, and contention, database, and the likes, but it's just not what DDD is really focusing about. And I mentioned language and meaning, right? So when we tease out the domain, we start to and we talk to the domain experts or our business counterparty, the business people. We start to understand, and we start to realize, or hopefully we start to understand, realize the way that they speak of the problem at hand, and the way that they try to shape, in their mind, how the problem at hand looks like, or what it should be solved like, or what the conceptual solution should be like, right? So it's all about trying to understand what do they mean, and what when they say again, when they say user needs to be able to deposit using through a, for example, pre-authorized deposit from their employer, what does that actually mean? Of course, you will probably have a guess of what that means, but the business tends to have a very specific view of it, right? It may want to reinvent the whole idea of pre-authorized debit or pre-authorized deposits, or it wants to reinvent the whole idea of interact transfers, for example. So we may have some inkling, some idea, and some presumptions, but it's really important to cross-check with the business side. Okay, you say this, but what does it mean for the business, and how does the business think of this, right? So trying to tease out the way that they speak and what they mean within the context of the business. Oh yes, and please do ask questions. So here's an example, and this is Eric in some presentation. I'm borrowing him for this. I actually borrowed a lot of stuff from him. And so here's a problem, and the problem is about in the context of a business that has like a shipment delivery software of some kind. And now within the software, they need to be able to depict a shipment in some form. You can imagine like getting some shipment data and then showing it in some UI, something like that, right? So Eric is asking here, well, what is a shipment actually? How does the business think of the shipment? And he proposes 3 examples. Cargo. A shipment is just a cargo with a series of stops that can be where the cargo can be unloaded and loaded, or a cargo can be a series of what he calls, or the audience calls, legs, where it determines from where the cargo is sent and to where it's sent to, or a cargo is something that has an itinerary, which in itself is consisted of multiple stops where the cargo can be unloaded and loaded, right? So which one of these are good representations of the problem at hand? Well, as usual, the adage of it depends kind of applies here. It depends. It depends on what the business wants to do. And each one can be good ways to solve the problem under the assumption that it is actually what the business wants to do. Right? We don't want to have, say, this representation of a shipment if the business is actually thinking more of this, that there is kind of like this middle layer of itinerary, whatever it is, right? But the business wants to focus, yeah, there is an itinerary. Maybe the itinerary can have a description or a name explicitly, and then it can be showcased in the UI or somewhere else in the system. And similarly here, here the language is unloading and loading. And this here, the language is from and to, right? This is about location. This is about action, which is 2 different things, right? And you can think of this like if you were to save and store in database, maybe unload and load is more like stateful information. From and to is more like informational information, right? Informational data. Different visualizations, and by eking out the language, the way that the business represents the problem, and the way that they talk about the problem will lead you to different solutions, or at least that's the hope in domain-driven design. Again, by consulting often with domain experts. And I tried to not use this word to introduce this word model, but essentially this representation that Eric is showing here, these three representations are three different possible models of the domain problem at hand. In this case, about shipment. And really, a model is about the abstract representation of the domain at hand, depending on how the business wants to think about it. And the model represents how we think about the particular problem at hand. It's not, we hear the word model in various ways. One of it often is like in entity relationship models, or maybe in database models, or we may think that models are a series of diagrams. Those are useful things in domain-driven design. Definitely, domain-driven design does not say you cannot use them or you cannot have them. I think everyone wants to have some kind of diagram because it's useful, but that's not the main thing when domain-driven design talks about model. Model is really just about how do we think about the problem. And the importance of model should be, hopefully, is clear to you, or hopefully it gets you thinking that if model is about how we think about the problem and it's kind of abstract, well, hopefully the model that we have is well translated into code. And what do I mean by well translated? I mean that the code that you make really looks as much as possible similar to the way that you think, right? And I'll show you an example later on where the model does not look very good, or the code does not represent the model. But part of the way that domain-driven design pushes you to do that, to make code that reflects the way that you think about the problem, is by using the language, using the language at hand. And I'll talk about it later on a bit more. But one of the important things about the model, and this is kind of like a side note, and I think it's important to know that often we have a tendency to try to create very detailed models, and even perhaps to say like realistic models, like very pinpointed, correct as much as possible. But funny thing is that Eric will say that that models that are realistic is a distraction, or more specifically, he says like realism is a distraction. The reason is because we want to make sure that models represent how we think. It's not the way that the world is. So that's very important. It's about how we think, not the way that the world is. And it should make sense to you, especially if, say, your business wants to be revolutionary, right? Maybe they want to change the way that that sprints are managed. We all know, or probably a lot of us know, about Jira as the from Atlassian as a tool to manage sprints and Kanbans, agile methodologies, right? And maybe your business wants to revamp the whole idea of how sprints should be managed through software. Well, if you just take from what is reality right now, you will never reinvent the tool, because you'll always be thinking in terms of, well, what is the current reality? So it's important for you to have a model that is kind of distinct from the current reality, but hopefully still makes sense. Makes sense in the sense that you want to solve real problems through your model, but you don't want your model to be constrained by reality. business love this because it makes your tickets and efforts feasible. Yeah, something like that, right? Business, we want to make this because we think this is useful for business and we think it's better than Jira, something like that. And I just put here like from someone like Nobel laureate called Professor Eugene Fama. I just put it because this was taken when I was still in fintech. But he says that a model is not completely true, and no models are completely true. They are approximations to the world. The question is, for what purposes are they good approximations? And I think this really cuts down to the essence of it, that models shouldn't be realistic. And Albert Einstein says that genius is taking the complex and making it simple. And I put it here just because part of the hardness or difficulty with modeling is really taking out all of the unnecessary things, even though it may seem necessary, and really constraining yourself to make something that is still useful, but simplified enough that you can reason about it and not make your head explode. And that's genius to do. Here's 3 again from Eric. Here's 3 models of the Earth, and this left one is the Mercator. I have no idea how to say it. Mercator map. I think that's how you say it. And this is a Dymaxion map, and this is just a nice picture of Earth from space. Very picturesque. But the Mercator map is the map that you usually see in Google Maps. The reason why Google Maps use Mercator map, one of the reasons, or at least, and like even in the map that you like paper maps, the reason that they use Mercator map quite a lot is because it preserves directional information from one point to another. It preserves that the angle also, like between what is actually in reality and what you can see in maps. So it's quite similar, and it preserves that information very well. So it's very good for navigation, especially if you want to know, well, I need to go to northeast from this location. You can see a Mercator map. Okay, so northeast is in that direction, and I will get to some location if I go to that particular direction. Right. The Dymaxion map, on the other hand, is very good at keeping the proportional size of the various pieces in the map, or the islands or the continents, you would say. In contrast, the Mercator map is very bad at keeping the size. This is Greenland and this is Africa. Greenland shouldn't be as large as Africa. Africa is way larger than Greenland. But in the map, Greenland is large in contrast to, or even the same size, or roughly the same size as Africa. But that should not be the case. I think Greenland is somewhere here, I believe, and it is definitely not as big as Africa. I think this is South America, and I think this is Africa, something like that. Somewhere around here is Africa. But assuming this is Africa, well, wow, Greenland definitely seems small, right? Completely different ways of thinking about the world, and completely different ways that are suitable to think about the world depending on the context. If you want to preserve size information, you will use this map. If you want to know about directional information, you will use this map instead. And if you want to see a nice picture of the Earth, I guess you can see this map, right? Not that this representation of the Earth is not useful. It's just useful in a different sense. Particularly if you want to enjoy the Earth. Fake news, everyone knows the Earth is flat. Well, it looks 2D, so I guess in a way it is still flat. But yeah, still talking about context. So I'm moving away to context now, and here's a possible scenario about customer orders or orders in, like, say, e-commerce website. So customer can make a order. And order will be processed by warehouse shipment, and the warehouse shipment will put item to the cargo for shipping purposes. The question is, are these orders the same, right? So hint, hint, possibly they are not the same, or possibly they are. But I made it explicitly separated just to make you think about how can it not be similar, right? And so let's iterate on some ideas on how it can be different. Some things that come to my mind, they have different data requirements for the two situations. They may have different validation requirements. Maybe they have different team responsibility requirements. One team is handling orders made by customer, and another team is handling orders to be processed by the warehouse shipment. They have different change requirements. And sometimes maybe one change for order here may conflict with the order here, right? So these are possible ways of how things can differ. So how will we know if we should treat these two orders as different? Again, by consulting the domain experts at hand and really asking them, okay, are these orders actually the same? Maybe they start off assuming also that these are the same thing. And it's, though they are experts, they're not they're not infallible. They may have problems in their own thinking of the model. And part of our job as software engineers and software developers is really to help them think also about the problem at hand, and really to help them tease out, okay, I want to know exactly what you mean, exactly, kind of try to disambiguate as much as possible. Sorry, I want to drink a bit. And so after consultation, maybe we reach to these particular model representation. It's not that the orders were the same; they were actually different orders from the beginning. One, the left side is a customer order, and the other one is a verified customer order, right? Which is verified by some kind of verifier system. So this is just one way to think about it. Not saying that this is the only way, but this is one way your business may consider the problem at hand and consider how to solve the problem. So once you really dig the model and try to extract the language and the meaning along with your domain experts and other stakeholders in play, what DDD really asks you to, okay, once you do that, try to use a common set of language. And by that, language that can be shared between the non-technical people and the technical people, right? So often, I think we talk about business requirements in terms of, oh, have to insert into database, user have to click a button, or user have to go to the web, and things like that, right? And that's all fine and all, but usually, details about databases, details about the web are not really pertinent to the business requirement. Often people may think so, but usually it's not the case. At least like from the business operational point of view, you can imagine, well, a business requirements that just says user submits order, order gets handled by some by system, right? Something like that, right? You don't even have to mention button. You don't even have to mention clicks. You don't even have to mention the web, and you don't even have to mention databases or servers or even anything like that, right? That's kind of like more of the core of what the business actually wants. And it's important for you to be able to share what is called a ubiquitous language in domain-driven design, and really it's just the language that can be shared amongst a non-technical and technical people. Because the ubiquitous language helps to shape the model. Now you can speak of the model and the way that you think of the problem at hand using the same set of language. And now since the model is important to be encoded into code, because the model is the way that we think, and we hopefully the code that we make reflects the way that we think, the ubiquitous language should also seep into code. And that will help you to deliver solutions that actually make sense, deliver solutions, software solutions that are independent of the technology decisions that you make as much as possible. Sometimes it's not maybe clear how that can be made, but as much as possible, the ubiquitous language can help drive that kind of solution or that engineering solution. So if you have a ubiquitous language, you will start to be able to carve up context, different ways to speak of certain things, right? So what does a language include? Language includes things like nouns, verbs, adverbs, adjectives. I said verbs already. Yeah, and other things. I guess I'm not so good with my grammar. A language consists of all of that thing, and different situations, just like the order example that I showed, may require different ways of speaking, even though at first glance, just like the order example, they may seem the same. And differences in the way you speak with your with domain experts and the way that they speak among themselves will help you to carve out what is called the bounded context, or just for more layman terms, I think contextually understandable language. If instead of ubiquitous, because you will think that ubiquitous is like everywhere. Eric says that, yeah, it's everywhere, but within a particular context. So there can be many ubiquitous language depending on the context that your business deals with, right? Obviously, your business may have different departments and different ways of thinking and different ways to refer about similar things that may eventually be treated differently based on how they speak about it and based on what meanings that they give to particular words and the way that they use it, etc., etc. Right. So there can be many ubiquitous language, or what I will just say contextually understandable language. So if we were to go back to the order example and just to contextualize it, right? Let's give some boundaries over them. We can imagine that there can be a commerce boundary. So this side is the commerce, and then another side is about inventory management, and this side is about shipping. Right? And you can imagine different teams and different departments dealing with only one, or hopefully only one, of these bounded contexts, right? So bounded contexts can also help you to decide how to organize your team, or who should be responsible for what and who should get access to what, based on, well, whether are they talking about the same context? Do they need the same context? Or are they really talking about their own world? So we're getting to the end. I have only a few more slides, and hopefully people are not too bored right now. So I want to just give some example, tying things together in more a technical fashion. Oh, sorry. How how many of you has worked with like log and metric aggregation systems like Datadog, Graylog, Splunk, these kind of systems? Or at least like not just like viewing, but like actually instantiating and setting them up. Just want to have a raise of hands. So I see one, Jen is there. I see Alex. Not sure who else, but yeah. So maybe some of you have, or some of you haven't, right? So just for those that haven't really worked and instantiated log aggregation systems, the basic gist is that the log aggregation system is just a place to collect all of your logs for various pieces of your systems. It may be your services, or it may be your web front end, or it may be your maybe your OS kernel, things like that. It can collect all kinds of logs. And most log aggregation systems also come with a metric aggregation system. So what that means is that you can build up metric information based on the logs that it aggregates. So some metrics that you can think of are like how many 404s happen for a particular endpoint, how many errors happen within the span of 5 minutes, how many calls to the database are made, how many cache misses or hits, and or how many requests are coming in, right? So all of that are metrics that are summarized through the logs. And often there's actually two models that the log and metric aggregation systems work. There's the write model and there is the read model. And the write model is very simple. It's just a stream of text. Log aggregation systems tend to think like, oh, a series, I just query raw logs at work. Maybe you want to suggest a log aggregation system, but continuing on, often log aggregation systems just get fed in logs through a sequences of text streams, essentially. So they're very simple. Send a string to it, it will ingest it, it will store it. The metric side of it has a completely different way of thinking about the problem. Well, it's not just a text stream, but it needs to compute certain things. And it needs to aggregate information. And actually, a lot of the time in log and metric aggregation systems, the storage for the log side, the storage for the log messages are different in compared to the storage for the metric aggregation, right? So completely different needs. One is for writing and one is for reading. It leads to completely potentially different ways of not just thinking, but also solutioning out. Because log and metric aggregation systems often identify, hey, it doesn't quite make sense to think of text streams for the reading metrics. We need a way to be able to massage text streams on the underlying text streams from the logs into something else, to a different shape, into a different information set, and store it differently, right? So so I just want to show from this like how, you know, within the same product there can be different models and different ways of thinking, and probably in this case different boundaries, right? There's the boundary for the write, and then there's the boundary for the read in terms of the aggregations or the metrics at the very least. So here's another example, duplication through context. This is just what I call it. So this is an example and that actually happened recently with my work. And it's kind of like stripped down, not exactly what happened, but it gets to the point. And the situation is that the user has an account, and account has a property, active or inactive. and also another property called first active at, and I'll talk about it later. And the user can make account modification request, and the account modification request itself is stored, and has and now we want to make a new feature that requires a new property called the account active or inactive. Now, here's the question that I asked the domain experts. Well, are these actually the same thing? And turns out that is not really the same thing. And what it actually is actually that the account active or inactive, this property is actually more about the activeness of the account at the time of request. So, and that's different from the active and inactive property of the account. And the difference is because active, the account can be made active and inactive multiple times throughout its lifetime. So it's just like kind of like a modifiable flag of some sorts, you can think. On the other hand, this property cannot be modified once it's created. It's just no way. It's just for informational piece. So this is state, this is information. If I had made this property refer to the same data source, that would have been troublesome for the problem at hand, because that would say that the way that we think about the problem is that these two properties are the same, even though the business does not think that way. Right? The business does not think that these should be the same because partly the lifetime of it is different, and the way that it changes is different, and really its meaning is different. Again, this is about information, and this is state, so completely different. Right? And I would want to just make a note of this first active at. One of the possible things that that I could have done is have a created at attached with this with account modification request, and I can infer account activeness by comparing the created at the time of the request with the time of the first active at. Yes, I could have done that, but that's not quite good to do so. At least DDD will tell you that's not good to do. The reason is because you are bridging boundaries in this case. This is the boundary of the account, and this is the boundary of the account modification requests. And it may be that in the future, first active at is modified to something else, not just in name, but in meaning. And it may be used in other ways that the account modifications cannot have control over. Right? And it's very bad to rely on something implied when it is not made concrete. If I had wanted to use first active at as a way to infer, I have to link account and account modification request somehow. At least this is based on domain-driven design. And in domain-driven design, this will be called something called the aggregate. And I won't go too much into detail about it, but just note that there are technical patterns that arises from domain-driven design precisely because precisely because you as a software developer, along with domain experts, have identified where things are carved and where things are bounded, and who should be responsible for what, or what should be responsible for what, and what should affect what. Right? All of these are eked out by talking to domain experts and understanding about language and meaning. And this is my last example. So I talk about the ubiquitous language, right? And ubiquitous language, to remind you again, is just about the way that both domain experts, non-technical domain experts, and technical experts experts talk about the domain problem and ultimately how they shape and think about the problem in terms of the particular language and the particular words and the particular vocabulary, etc., that they use to identify. So here's an example that is very bad. And this is actually in the code base in my current company, but I think this is very bad to do. The reason is because upsert is a very technical, or tends to be a very technical detail. And upsert is very rarely thought of as a business operation or a business thing. At least I've never really encountered a non-technical person that says the word upsert, which is, if you don't know, upsert just means update or insert. So this function says that, okay, about the technical thing it needs to do, but it doesn't tell me, well, what is it supposed to do in the business? What is it supposed to solve in the business? And after some digging, I actually realized that upsert brand account should maybe be called do X after admin approval. So there is some admin approval phase that happens, and then this function is called. So ultimately, that's what it's all about. It's about doing something after some admin approval. It's not about upsert. That's not what the function is doing. Yes, maybe technically that is what the function is doing, but that's not what the function is trying to solve. Or at least I hope that's what the function is trying to solve for the business. Oh, sorry. So I just want to end my presentation just to say, like, why do I think DDD is important, or at least, why am I presenting about DDD? Primarily, it's because I think we are doing DDD. Every one of us is implicitly doing domain-driven design in some way or in some capacity. It's just that we don't have a formalized way of speaking about it. Domain-driven design, the essence of the philosophical concepts of it is really to formalize what we have always been doing. We have always discussed using language, and we have always tried to understand with the business, what should we make? We have always made assumptions about how things should be, and we have always tried to put context and meaning into the things that we do. So every one of us is doing domain-driven design, just not formalized. Domain-driven design really formalizes things, give words, and terminologies like ubiquitous language, bounded contexts, domains, models into the things that we have always done. And it's important, even though you may not use eventually the technical aspects of domain-driven design, you can use ideas from domain-driven design to better understand what exactly are you doing, and to really try to formalize and not be ambiguous with what you're doing. And hopefully through that elimination of ambiguity, you can create software solutions that, again, reflect what exactly is your business trying to do through your code. So no longer of things like doing upsert, but actually saying, I'm doing this because this is what the business wants to do. So I guess, like, what's next in terms of, I guess, like my talk. As you see, it's blank because blank. I don't have anything like up next, but hopefully I will be able to, in the next 6 months or so, have a DDD-based application example in JavaScript or in Node.js, just to make it a bit more concrete. Yeah, when I make that, hopefully I will be able to make another talk. So looking forward to see you all. If you do decide to come and not get bored, hopefully, with my talk. So thank you, everyone. I think I can share this slide since I just made it public, and I can put it somewhere maybe in the Slack channel for Toronto JS, and you will be able to access the notes and also some of these references and further readings.